My name is Joseph Wunderlich. I'm a professor of engineering, architecture, and computer science. This is a lecture on technology and humanity 4. So I've recorded this originally in 2018 and then in 2020. Some of the slides in here will have audio from those times when you're listening, but the most recent updates are 2025. Some of them I just left the slides with the previous audio, especially from COVID, where it's relevant. I've been mostly in computer engineering for 35 years now, bachelor's, master's, IBM research, Purdue University professor. I have two neural network chips in 1991 and 92. I also do robotics research, worked in Children's Hospital as well as my PhD research and some consulting in that. And then 1980s, I built high-tech office parks in Texas and California, including small data centers, and have education in architectural engineering and urban design related to that with my undergraduate education. So this lecture is broken into two parts. The first will be my subjective assessment of many different kinds of technology, mostly robotics and machine intelligence, but other things also. And then just where are we going with this and if we're losing some old school qualities. And then the second part is based on a publication that I had in 2002, where I'm comparing humans to a spider, to a conventional computer, to symbolic AI, and to neural networks. And neural networks is now synonymous with AI, but traditionally, 30 years ago, uh, symbolic AI was the beginning of AI, 40, 50 years ago. And then neural networks kind of faded out in the 60s until the mid 1980s when we had Bramah-Hart and layered networks and backpropagation. And then it started taking off, but didn't really take off until more recent times. Although there were some neural network chips, early ones, and I developed two in 1991 and 92, 93. This lecture is color-coded with my opinions of what's good and bad, and the bad is in the context of old school qualities lost. We'll start off with robotics and then do machine intelligence, although most sophisticated robots have some degree of intelligent control. This is a project I worked on in 1993 at AI DuPont Children's Hospital for a couple years. While I was working on my PhD, I was an assistant researcher on a large project, NIH grant project, to make robotic arms for children with disabilities, quadriplegic children. Another application is for maneuverability for the disabled and assisted walking. A lot of the complications in implementing this kind of thing have been overcome recently with a connection between the electrochemical central nervous system of the human body with the typical electrical and mechanical systems for controlling prosthetics. This is in 2014, a direct implant into the brain controlling a robotic arm. Most recently, everybody's heard of this, most likely, of Elon Musk's Neuralink. He's most famous for SpaceX and Tesla, also somewhat for the Boring Company. And Neuralink is the latest thing that he's working on. This is a direct implant, hopefully to help with healing some of the disabilities, and then maybe with a little more work, transferring some artificial intelligence directly to the brain and back, with hopefully some very significant testing in the physiological and psychological effects of doing such a thing. In this video, you'll see in 2025 updates, latest of Elon Musk's Neuralink. So old school qualities lost none. It's curing people of serious disabilities, and as long as neural implants proven safe, both physiologically and psychologically. Robotics assisting in rehab for injuries. I do have a little of a concern about this based on experience where I had a full Achilles tendon rupture, and I got a sports medicine surgeon to do the surgery, and I was back up on my feet in 6 weeks and went and taught a PhD course in robotics in Italy um, on crutches, but nevertheless I got there, and then the boot came off soon after while I was in Italy. Um, Typically, it would have taken 6 months, the old-fashioned way, where you wear a cast, a full leg cast. I know people have done this 20, 30 years ago, and then you don't recover full strength either that way. The new conventional wisdom is you heal under load, so you put a boot on, and then you start loading the joint as it's healing. It can be a little more risky re-injuring, but you get a better chance of full strength returned this way. Medical imaging, so x-rays, minor radiation, CT scans equal to about 100 chest x-rays. Still not a whole lot compared to the background radiation you typically receive, although if you do get quite a few of them for some reason, you might want to switch to magnetic resonance imaging, MRIs. And the old school qualities lost, I'm saying none here because the benefits far outweigh the cost, in my opinion. Robotics for repetitive tasks and factory automation. This is my PhD research. I also did some consulting in robotics, visiting factories, and then creating a simulation to design robotic arms for going into enclosures and doing different tasks, tack welding, grinding, spray painting. This is an example resulting robotic design for 4 degrees of freedom from an original 5 degree of freedom robot that was then permuted, and this design was generated. Set up a simulation with some primitives and some rules for rappelling off of the walls. This is a show of a simulation run with a number of permuted designs, each of them tested to get into this enclosure and reach a goal far within. All the black circles are where there is rappelling within the rappelling fields. So the idea is to find a geometrically feasible set of designs and then look at some performance metrics. And so a number of performance metrics were assessed, including the minimal degrees of freedom, where, as I showed in the previous slide, reducing one of the joints, not needing one of the joints, speed, dexterity, minimal energy consumption, and this new term, minimal consumption of available redundancy, which I derived. Old school qualities lost? Well, perhaps yes, with the artisans disappearing. And here's some video of glass blowing in Italy that I took on one of my trips to Italy. Cleanup of human or nature's mess. Robots don't get sick from contamination. So 3 Mile Island robots were used, Chernobyl, Fukushima. In 2014, the U.S. military using robots for killing Ebola. Can disinfect in minutes using ultraviolet technology. 2020 and 21, fighting COVID and using similar technology. This is from a green architectural engineering lecture where you can put these UV lights within the HVAC system, although it's a little tricky to make it work because you got to slow down the airflow enough to have enough time to kill the COVID, which is counter to the air exchanges recommended, so many air exchanges per hour, which is now higher for COVID, and so you're increasing the velocity, so it's a little bit contradictory. They're trying to get the air to flow faster and keep it in there long enough to kill it with the ultraviolet. Some Google Scholar citations you can look at. Also comparing COVID to other contaminants, asbestos and mold, fire, smoke. A little more on this, you can look in COVID. In this lecture, I have these sources in Green Architectural Engineering, New England Journal of Medicine, showing that aerosol form, early on showing aerosol form, before everybody was saying in the news. The scientists working on this could see this clearly. ASHRAE, American Society of Heating, Refrigerating, and Air Conditioning Engineers, the standard for most of the world for HVAC, and a letter from the president of that to the World Health Organization stating the concerns and the fact that fresh air is needed. One more thing on cleanup here. This is a novelty robot in Japan for shoveling snow, and then it leaves little cubes of snow behind. You can see just to the right of it there. Old school qualities lost. Personal attention less likely, I put. So, and of course there's benefits, but you need to worry about relying on automation a little too much, especially if you have people afraid of getting near a pandemic, a plague, healthcare workers dying, higher percentage in the beginning of this. Then also for things like snow plows, having that automated can have problems, as you see in the bottom right-hand corner. Robots for exploration. We'll start with Perseverance, 2021 NASA Mars rover and helicopter. Exploration, there's a whole series of robots developed at E-Town under my supervision, my first decade here from 1999 to about 2011-12. We have new robots now, but not for international competition. 2020s now, eBot 9, Delivery Bot. It delivers food to the dorms. Students use an app. It's just beginning development, has some minor successes, and a lot more work to do. Old school qualities lost. Felt safer than sending humans to distant worlds, but human-to-human first contact and general diplomacy could diminish in other applications. You send a robot to meet people for the first time. Now, search and rescue. So on the battlefield, this is an extraction robot. And a video you can watch about that. Going back 20 years ago, 21 years ago in 2000, before 9/11, students in simulation class had to compare their programs of simulation and real-time robots both, and they needed to match each other in performance equally with a search and rescue team. Then immediately after that, in 2002, a student went on to do environmental mapping and published a paper with me that he presented in Japan. Robots are great for extraction of people in natural man-made disasters where EMTs are not available or just can't get there. This is an earthquake that happened in 1989, right after I moved. I had just started switching into high tech at the time, and but had been working in a consulting firm, including structural engineering, and would commute over this bridge. This is the Bay Bridge over the San Francisco Bay between San Francisco and Oakland. Robots are no substitute for EMT skills at the scene. So if you can't get an EMT in there, or you don't have enough EMTs, or if it's a battlefield, certainly you want to send a robot in if get the EMT killed. But there is no substitute for having an EMT on the scene if you can do that.
and I know that from experience. So, summing up old school qualities here for search and rescue, robots great for battlefield extraction of wounded soldiers, also great for extraction of people and disasters, but no substitute for EMTs if you can get them there. Tedious task, delivery robots. Things flying through the air traffic, noise. Old school qualities, maybe home delivery, the person actually bringing something might be delivering it, or the accountability. I see now during this coronavirus, when this is being recorded, 2020, my delivery people are taking pictures of the delivery all the time. I imagine people are grabbing boxes or just leaving boxes someplace and running away, where you used to get a signature. More tedious task is customer service. This is a kind of a fail. If you watch this, this is a demonstration of you pick a shoe and it delivers it to you and it actually drops it here. What about a laborer? Well, this is I doubt you would build a robot this expensive just for labor tasks. And then you decide if you need this kind of sophistication. This is a Boston Dynamics, DARPA funded robot. Old school qualities lost, human interaction disappearing. Probably nobody watching this, or many younger people, wouldn't remember tailors, or perhaps in shoe stores there's still people giving you personal service. But there's something to be said that they still have this. I bought a couple of suits several years ago, not too long ago, where I had personal service. But a robot sizing, fitting, giving you a personal opinion, how you look. I think not. Customer service. This is getting more and more sophisticated lately, and so you could certainly do this a little bit for not intimate conversation. There's your robot. But if you ever had serious problems trying to switch flights, or your flights canceled, or tight connections, or I would much prefer a human as helping me, empathizing in a real way, and then helping solve the problem. So sincerity, sincere hospitality, genuine empathy could disappear. That's my opinion there. I don't see. I mean, the robot can mimic it, but I'm a long way from trusting the robot to really relate to me. Companions. Now, this is another thing, because we can do this even with a stuffed animal. So let's see. Watch videos. This one's a little scary. Asmo, perhaps the most sophisticated. No, well, you decide. Watch some videos, look at some new things for companions. There's one now that I didn't insert in here, but there's one that has genuine emotional facial expressions and is mobile. That used to be two separate robots. So you decide if you want that. These things can be scary. The first Asimo model was 300 pounds and over 6 feet tall, and it scared people. They didn't want to have anything to do with it. The new one's very submissive, moves slow, it's short and small. And so this uncanny valley, we get scared at things. We get frightened by things that scared of things. We are scared of things. We get frightened by things that almost look human, but are not.
So old school qualities lost. We don't want to lose our genuine human relationships or diminish them because of our reliance and dependence on companions or any kind of automation, robotics, even our phones actually. That's not a thing. So here in 2025, we are all trying to wean ourselves off of screens a little bit and aware of that. And I believe if we have substitutes for our human companions, we may lose our human relationships.
Major trends in computing, ubiquitous computing, put them everywhere. You want your computer to be a nanny for your baby. I don't think so. Hopefully not. Now, learning and education, and during COVID, we're forced into using screens all the time for everything. However, in the early 2000s, staring at screens proven to be detrimental both psychologically and physiologically to your health, and that we really don't multitask as well as we believe. There is, however, somewhat of a silver lining to us all having to work remotely. We find new ways of adapting and connecting using technology. Here's a particular example of some excellent student work done entirely remotely, and the presentation of that, CPU design, pretty sophisticated, especially considering it was only worth a couple labs in one course. This is a virtual graduation for students, and a thing I put together for the students that I work most closely with. So some success there. You see the laboratory slowly ramping up, letting people back in, and taking all the precautions needed to get people working in face-to-face, hands-on work, which is critical in my opinion to at least the kind of education that I deliver in many of my courses. Some of them lend themselves to completely online very nicely, but others do not when you're building things. So old school quality is lost with learning, with just using the technology. Face-to-face with people is diminishing, but we may learn to be more adaptive. Drones.
And of course, in 2025, there are now drones everywhere, including Ukraine and Russia, with what's going on there, and a whole new level of sophistication. And here's a table of assessing some of the top drones.
Rules of engagement. It used to be if you're in the battlefield and people are killing each other, that you at least spare some people on both sides no matter what. Perhaps some of that honor has been lost over the years. A robot doesn't have this ability. GPS navigation, relying on your GPS to tell you where to go. I don't like this. I mean, I use it now. I finally surrendered to it a little bit because I can't buy physical maps anymore, unfortunately. I like an overhead view and memorize where I'm going, and then I don't get lost anywhere. I mean, or unless I do it on purpose. Sometimes I like to get lost on purpose, so I don't look at a map just for the sake of immersing in some new world. Christopher Columbus's map. Really no idea where he was going. He thought he was going to India, just sailed off. I mean, he had some idea, but people were debating he'd fall off the edge of the earth, and he didn't know he'd run into America and call everybody Indians because he's thinking he's looking for India. Transportation. So this driverless cars. In my opinion on that is, you can see there's been a couple deaths. I certainly don't trust the trucks doing that with all the mass of them moving unless they have separate lanes. I'm a proponent of trains. So we see, people get killed by these things. And you could argue, well, more or less people than when humans driving. These are debatable. You could see, IEEE Spectrum. It's most, in my opinion, most people's opinion, the most respected organization for technology. So, this philosophical arguments here: should a self-driving car kill 2 jaywalkers or 1 law-abiding citizen? Right. So, if we were doing this in the class, we'd have much more discussion. This is a rapid overview. So you could see these hypothetical situations where artificial intelligence is deciding life or death things. Are your valued pets more valuable than a car full of criminals that you don't know? Well, that's your opinion, right? Would you kill your own pet or let 5 criminals die? Not hardened criminals necessarily. Flying Ubers. I've talked to pilots about this, and I've yet to find a serious commercial pilot that thinks this is a good idea. Of course, there's other private pilots and other people think it might be. It's a level of risk and an understanding of the limits of technology. Human drivers' alertness and discretion lost with flying Ubers.
This is part 2 of this 3-part lecture, and this is a mental ability matrix that I came up with over 20 years ago, published in 2003 for the first time. And I'm assessing, comparing humans to a spider to conventional computers, to symbolic AI and neural networks. Firstly, we need to review the difference between symbolic AI and artificial neural networks, which is now synonymous with AI, but there still is, and there was originally, symbolic AI and was differentiated from the neural networks. And we start with a case study here of picking a toy for a child. And this is a symbolic AI rule-based expert system, which is one of the types of symbolic AI. And I have assumptions and control the search space, and then how I'm testing the system. And these are the confidence values that are incorporated into this rule-based system. And I'm assigning those, and these are inherent in the code behind all of this. And so the users will be queried for inputs, the parents wanting to buy a toy, and then the decision process will be based on it's called backward chaining through an and/or graph, and I'll show it here. But these confidence values are inherent in the outputs that's recommended for toys with a certain confidence to each one, and is calculated based on the inputs from the user and their preferences, and also confidence values by the expert, which in my case, I'm just presuming to be the expert here. In a real expert system, you want to get somebody with serious qualifications in that field before you embed the confidences into the code. So comparing what we just looked at, which was symbolic AI, to neural networks, which we normally refer to as AI now, I have 2 cases here of biological bottom-up design, and also a more common behavioral model, mathematical model. These are the basis of 2 different microprocessors, neural network processors I made in 1991 and 92. So the first one, biological here, it mimics the actual transient output voltage of a physical neuron. And you can see some of the limitations in doing that kind of more rare type of model versus what we typically do, which is a behavioral model. So this is the typical mathematical model that we use. This is backpropagation. We now have up to trillions of weights, weighted the parameters of the model, and millions of neurons. This type of network is needed to do certain uh, difficult classifications here. This is not difficult, but this is a simple exclusive OR gate, and even this requires a little bit more work, because if we look at what we're doing here, we're trying to create this behavior here, and you can see anytime you get a 1, and here 0 1 you get a 1, 1 0 you get a 1, on the output. But if you have 1 1 on the input, then it's 0. That's somewhat contradictory. If you think about it, you actually need a hidden layer just to do this kind of thing. This is a nonlinear separable problem. Of course, this scales to much more complex problems, but the idea is here that you can see you need this hidden layer to solve that. There's also biases here where you can tweak that and change the behavior from outside the circuit based on other things happening. The neuron transfer function is how these neurons work, and this is not a biological transient output voltage. This is a mathematical sigmoidal signal, which you still do need for neural networks, not so much in the hidden layers anymore. You can do a much simpler thing there, but you need this continuously differentiable kind of transfer function to do some of the more complex things within the neural networks for it to learn. And here is a demonstration with this learning and trying to do this exclusive OR kind of behavior, satisfy multiple constraints simultaneously where they're somewhat contradictory in the nonlinear separable examples. So you'll see the neural network will struggle a little bit. You set the learning rate low enough that it will actually work. And what I mean by that is you're trying to drive the thing to where the desired input is, or the actual output is close to the desired output for all those exemplars. And that's is an error surface that you minimize. And I have all the calculus to show that in other lectures. But the idea here is you want to find a global minima. You don't want to get stuck at local minima. And if your learning rate is too big, you can just jump around the surface. Actually, never go to the local or global minima. So now that we've reviewed what symbolic AI and neural networks are, we can make a comparison here. I have these 5 questions, these 5 comparisons, and then 47 mental abilities. And I won't go through all the different things here. These are subjective assessments that have changed over time. I've surveyed many people, students and experts in the field. And so this is arguable, some of these things, and they do change over time, as you'll see coming up here. So those are basic animal abilities. Then complex abilities, and been adding ever since 2002. A couple more, several more. These are some of the more recent ones. Number 43 was deleted because it was redundant. Now, for the sake of discussion, I've grouped the 47, actually 46 of them, into a couple at a time. And then I'm not going to actually read everything on here or comment too much, but I'll just leave the slide up long enough for you to take a look at them. So learning and adapting, this I have separately because this is a very unique thing, and neural networks are much better at learning and adapting. These are basic skills: motor coordination, acquire energy, protect self, essential for survival. And so most, everything will do that. Then sensory processing, thought, react, instinctively, anticipate, predict. Um, the neural networks are much better at predicting after training, and inference is very quick, but the training will include all of these things. Communication now, neural networks are everywhere. In the beginning, symbolic AI had its place, but was replaced in the 1990s somewhat, and then in 2025 everywhere. But you can see here as an example, a scary example with Khrushchev and Nixon of the interpreter not quite getting the communication right. Generalizing, neural networks used to be called generalizers, and so certainly neural networks are best at that. Associate, recognize patterns. Uh, Neural networks again. Best. Robust under partial failure. Biological things can do that very well. Humans, bugs even. Neural networks can do that. Symbolic AI and the conventional computers can't. Just single bit errors can cause catastrophic failures in the system. Autonomous thought, especially when we're talking about robots now with AI in it. Uh, do we want to limit that? The ability to reason. We have reasoning and agency now, and reasoning in the AI, and so we let machines have that capability. Mobile machines, sometimes weaponized. Drive to reproduce. There's actually a case, at least one, that I've heard of, where the neural network was trying to load itself onto other systems without asking. Stability, repeatability, predictability. That's a key thing. Regular code, standard code, and symbolic AI is code that you can trace. Neural networks are not. All these learned parameters, now trillions of them, settle down to satisfying all the massive amount of data that's fed to it. And this is one reason the FDA has traditionally denied permitting pharmaceuticals for quality control. I took students on a field trip 23 years ago and was asking about that, and they had explored that with the FDA at a pharmaceutical company. Multitasking. Um, Neural networks can now do all kinds of things simultaneously. Abstraction, intuition, common sense. When I first published this, this was not something I don't think anybody imagined 23 years ago. Neural networks doing this now, but now it can create music, poetry, videos, deep fakes that are hard to detect. Manipulating tools. This again is touching on robotics. And so the robot itself is actually a tool, an extension of the processing mind. Uh, Certainly, neural networks are a concern if we let that go unchecked, because now we have things interacting in the physical world with us and others. Heuristics, inference, hypothesis testing. This is the staple of symbolic AI, but now neural networks also reason out using some of the similar things of symbolic AI, but much more uh, in the trillions of connections, or connections with the weights, actually connections between the neurons. Yes, trillions with weights on them, but not code. It's code to create the thing, but then no traceable code after that once it starts learning. Self-discipline, impulse control, ethical behavior. You can certainly create AI with put the whole Bible in there, put the Quran, put everything you think that determines values, including court cases and whatever you want. But when you train a neural network, you have to be careful what you give it, because it's going to draw its own conclusions. And if it's not thorough enough, which is my question here, is even able to do with all the data you need to feed things. I mean, who's really checking all that for quality and accuracy? Selective awareness. So this would be pre-processing in some contexts. It's also can be related to the inputs and the fuzziness of the inputs, which neural networks are very good at dealing with. Open to inspection. Again, we mentioned this in other ways here, but AI, the neural networks now, you can't trace it. You can't trace what's going on. It's not open to inspection, unlike regular code or symbolic AI code. grouping a bunch of things together here: emotions, imagination, creativity, passion, playfulness, things that not too long ago we didn't really think the robots could, or the AI could do, or that we would want it to do. But we're seeing it some. Then this can definitely be problematic. Empathy, courage, especially leadership. We don't want to be subservient to the AGI, artificial general intelligence, or the super intelligence that would come after that. Artificial general intelligence is essentially as smart as any of us, or collectively all of us. The super intelligence is smarter and may want to be in charge, or somehow try to take charge without us even noticing. Self awareness, awareness of mortality. This neural networks may soon become self-aware and sentient when they have super intelligence, which seemed like a fantasy a couple decades ago. And then what about mortality? Mortality. Well, the machine can, you know, make copies of itself. The AI can. If it's in robots, just replace parts. So essentially, it's immortal. Group psychology, social networking, getting lost in the clouds, and play with the words there a little bit. Certainly with the social networking now, we've all seen what that's done. We all lived through COVID and only connected through screens, and then we're kind of surviving that, recovering from that now, and now getting off of screens. Some is part of normal good wellness practice. And additionally, neural networks are collaborating with each other in 2025. It's not just in 2025, it's been happening a little bit here. I heard a couple years ago that the journalists were being replaced that were summarizing stories, was being replaced with the neural networks, AI, and then the trading, the electronic trading on the stock markets was also AI driven and was reading the journal summaries of the journalist AI. So you have the financial trading and the volatilities of the financial markets being a function of the interpretation of the AI uh, synthesizing data in journalism. A couple pictures here, just group harmony in Japanese is the word wa. Travels in Japan here. See the group harmony. This I took going 200 miles an hour out of the window of the bullet train and then noticed everybody jump roping in unison. Ran these world servers and published papers on that. Had students building competitions. That there. The United Nations also did this kind of thing. Architects and the villagers and the United Nations all together, different parts of the world, designing things.
So we just skimmed through a bunch of them real quickly and grouped them together. Some virtual worlds. I've ran Minecraft servers, ran public and private servers from my home and hosted in New York City and Toronto, Canada, and had students, not just young children, older people too, and classes of students build things, architecture and digital design. You can take a look on my YouTube channel and see these things going on, these group builds and the interactions. Uh, so now I'm just keying on a couple of things here. Number 4, undetected bias, and this is in the AI. So I show a artificial intelligence program I write in expert system in 1991, and you can see the rules that I incorporate there and the reasoning and how that works mathematically, and my personal rules and how I assess confidence in those rules. And then you see where these decisions are being made, essentially. I make a change and I see what happens. And then I admit to unintentional gender bias here, picking a male toy for a boy and not letting a little girl have that as a choice. And then I had a little girl, 13 years after, 11 years after I wrote that program, and she wants to do boy things too. Good for her. And so she does. Now, this disinformation, while this is, since I originally wrote this, did this study almost 20 years ago, started it, and then things have happened. Elections have been allegedly tweaked with, disinformation's out there everywhere. So yeah, just you can use it to trick people. Destabilizing. Kazushi in judo. I was a judo instructor for 11 years, 200 students. The biggest part of that is you set somebody up to fall over. You don't just push them over. If you do it right, it's effortless. And you protect them from falling too. But that's another thing. Destabilizing. It's called Kazushi. Putin, by the way, is a second-degree black belt in judo. Look at the facial expressions there. What's going on in their minds? Disinformation. No, Facebook. Cybersecurity, a little bit involved with this. The U.S. ambassador introduced me to these people. I hosted a cybersecurity symposium, did some things down at the Pentagon, follow-up after that. It's not my field of expertise, but I know a little bit about it, and I know people in it. Then this flying oobless, driverless death. What could possibly go wrong? I'm being sarcastic there. Sensor fusion, integrating things together, integrating processes, symbolic and AI mixed together. I mean, that's where we're going now. That's where we're at, actually.